Hello everyone. We want to continue with the lectures on the topic of limit computation, and this time we are dealing with some functions where radicals are involved. We want to find the limit of square root of 4 minus x minus 2 in the numerator divided by x in the denominator when x approaches 0. So it's not a secret that if you apply direct substitution method, you end up with square root of 4, which is 2, minus 2 in the top, which is 0, and the bottom is also 0. So this is actually another indeterminate form. Indeterminate form. So the question is, how do we find the limit? In this technique, what we do, we start rationalizing. And generally speaking, if you have an expression in the form of square root of a minus square root of b, there is another expression, square root of a plus square root of b, which is called the conjugate radical of this expression. So if you have root a minus root b and you multiply it by root a plus root b, okay, in that case, using difference of squares, or by just using FOIL, expanding, we will end up with a minus b. And in this way, you see that all the radicals are gone. We eliminate all the radicals. So when you have an expression in the form of square root of a minus square root of b, you can multiply it by its conjugate radical, which is square root of a plus square root of b. And what is the point of doing that? What is the benefit? Well, the benefit is that when you multiply them, you end up with an expression without any radicals, just such as a minus b. So we use this idea, and we are going to rationalize the numerator. So if the numerator is square root of 4 minus x minus 2, okay, I'm going to multiply the numerator by its conjugate radical. So it becomes square root of 4 minus x and then plus 2. But the thing is that when you multiply the numerator by an expression, you can't change the problem. So you have to compensate that by multiplying the denominator by the conjugate radical as well. So we have square root of 4 minus x plus 2. So the same expression that you multiply the top by, you multiply the same expression by the denominator. This way, these two basically cancel out each other, and we have not actually changed the problem, which we're not supposed to. Okay, so now we have a minus b times a plus b. So that's a squared minus b squared, clearly. But the a squared would cause the radical to be eliminated. So we have 4 minus x minus 2 squared, which is 4. And in the denominator, of course, we will be stuck with the expression including the radical. So this is what we end up with so far. So square root of 4 minus x minus 2 times square root of 4 minus x plus 2. If you multiply either by expanding or using the difference of squares identity, it will be this radical squared, which is 4 minus x, minus 2 squared, which is 4, right there. The denominator remains unchanged. We can't do anything about it. But now 4 minus 4 in the top, it becomes negative x, because 4 minus 4 is 0. So we have limit of negative x over x and the rest of the radicals. So if you simplify negative x and x from the bottom and the top, you end up with limit of negative 1, which is left over in the numerator, and the denominator remains unchanged. So we're going to see if the direct substitution method works this time or not. So if you sub in 0, square root of 4 is 2, 2 plus 2 is 4, and the answer is negative 1 over 4. So the limit of that function, which was indeterminate earlier, now it turns out to be negative 1 over 4. So this technique of computing the limit is called rationalizing technique. because that's what we're doing. We are rationalizing the expression in the numerator. Well, sometimes the expression is in the denominator, like in this next exercise, and we need to rationalize the denominator. So I'm going to continue doing all these questions, perhaps a little bit faster now. Needless to say that if you sub in 4, we end up with 0 over 0. So that was indeterminate. You should always check that first, mind you. So I don't even mind, showing that I checked it actually. So this is 0 over 0 if you substitute 4. So direct substitution method doesn't work. So this is indeterminate form. Okay, so now we start multiplying top and bottom by the conjugate radical of the denominator. So we are rationalizing the denominator this time. We place the brackets properly. The bottom becomes 4 minus x. The numerator, it is actually x minus 4 times 2 plus root x. X approaches 4. Now we see that x minus 4 and 4 minus x cannot directly be cancelled out. But if you factor -1 out in the denominator, then you can. So we end up with limit of negative x minus 4. So now we have exactly x minus 4 in the top and in the bottom, both. And now x approaches 4. You can cancel x minus 4. You will end up with limit of 2 plus root x over -1 when x approaches 4. And that will be, of course, 2 plus 2, which is 4, divided by -1. Final answer is -4. Next question, we have the radical expression in the numerator, so we need to rationalize the numerator this time. Here we did rationalize the denominator by multiplying the conjugate radical of the denominator. Okay, so let's try this. It is, of course, you plug in 11, the square root of 16 is 4, so we end up with 0 over 0 again, but rationalizing the numerator, we have to multiply the top and bottom by the conjugate radical of the numerator with the plus in between the radical and the 4. Okay, so now the numerator will become x plus 5 minus 16, because 4 times 4 is 16. If you do the expanding or apply difference of squares, you get the same answer. And the denominator, of course, remains unchanged. So x approaches 11. Simplify the numerator. You get x minus 11, because 5 minus 16 is -11. And perhaps we found a common factor in the numerator and denominator that can be cancelled now. So what is left in the top is square root of x plus 4. What is left in the top is just 1, because we cancel out x minus 11 from top and bottom. What is left in the top is 1. What is left in the bottom is the radical plus the 4. So if x approaches 11, then the radical will approach square root of 16, which is 4. 4 plus 4 is 8. So final answer to this limit is becoming like 1 over 8. This next question is kind of interesting, maybe a little bit hard. Years ago, I gave this as a test question, mind you. We have radicals both in the top and the bottom. So in this case, if you're scratching your head and if you're wondering, just like this second example, if you're wondering if we need to rationalize the denominator, or like the first exercise, we need to rationalize the numerator, then I should say we have to do both. So first of all, if x approaches 3, the top approaches 0, the bottom approaches 0, it is the indeterminate form. Okay, we're checking because sometimes it is not indeterminate form, and direct substitution method actually works. So I'm going to multiply the top and the bottom by different expressions. So first of all, root 7 minus x plus 2, and same thing in the bottom, of course. And then this is the conjugate radical of the numerator, but the conjugate radical of the denominator is 1 plus square root of 4 minus x, and I should multiply that by the numerator as well. You see, I put proper brackets, so now everything is fine. The product of these two expressions would be 7 minus x minus 4 times 1 plus root 4 minus x. We are rationalizing both the numerator and the denominator. The product of first and last will be 1 minus 4 plus x. Okay. And then this orange part remains unchanged. Okay, x approaches 3. And then we see what is left over. 7 minus 4 is 3. So that's 3 minus x, 1 plus the radical in the numerator. In the denominator, we have 1 minus 4, which is negative 3, so that will be x minus 3. And then the radical plus 2 when x approaches 3. You see that every single line starts with the word limit. So you must write limit at the beginning of every single step of it. Not even one should miss the limit. Now x minus 3 and 3 minus x, they can be cancelled, except that we need to factor negative 1 out first. And when you factor negative 1 out here, you can put that negative 1 outside of the limit according to the constant multiple rule. According to the properties of limits, we can write that negative 1 actually outside the limit. Okay, and then we can have just x minus 3. So we factor out negative 1, it becomes negative 1 brackets x minus 3, and that negative 1, which is like in front of the limit, we can just pull it out and write it outside. 1 plus the radical, and now you have exactly the same expression clearly, and you can cancel them, of course. Okay, so these two cancel out each other. We end up with negative limit of a big radical expression in the numerator, another one in the denominator. So if x approaches 3, the top approaches 2, because 4 minus 3 is 1, square root of 1 is 1, and the denominator would approach 2 plus 2, which is 4. So the final answer is negative 1/2 for this question. Okay, so far we have learned a few techniques of limit computation, and this was just another technique called the rationalizing technique. I give you more than enough examples, I should say. You should sit down and do so many questions and practice enough so that you become fluent in these type of limit questions. I will give you more techniques, more methods of finding limits of different functions in the upcoming lectures. Thank you for your attention.